If no questions, then it means that you didn't hear me, okay? So, now this thing doesn't work. Right. This thing doesn't work, so I will have to use something else. Okay, my name is Anton, and I'm a big fan of open source, and big fan of... Oh yeah, actually, good idea. You see, we fixed printers, we fixed sliders. What else should we fix? Excellent. So, still, my name is Anton Babenko, and I'm not from warm place as previous speaker, so I get used to snow. I live in Norway for the last 13 years, and less than that, I try to stay active with open source, and for the last 3 years, I'm actively contributing and having fun with Terraform, AWS, organizing different events like DevOps Days in Oslo, different user groups, travel around and try to make people aware about these technologies and how to use them properly. So some of you probably are familiar with Terraform, so I just would like to hear faces and hands who know what is Terraform and who use it daily. Right? Okay, good. So it's about half of people. And I think some of you actually use code which I wrote or which I contribute to or which I maintain for the last 3 years. Terraform AWS module is one of the most popular one, which was downloaded 2 million of times and for the last year, and a few other projects related to Terraform. I actively stay in the community and listen in what kind of questions people constantly ask me, like how to structure my projects, how to solve this thing, how to do that better, and so on. So 3 months ago, I started writing Terraform best practices, and it has not been finished yet because things are constantly changing, and I have to earn money, and I have to find some customers. I'm not employed by HashiCorp, as you may think, but nevertheless, I write a lot about different things. So if you have questions after this talk or about Terraform, feel free to find me by my nickname. This nickname is everywhere. And if you are thinking, what is this module CF? Yes, I have logo for this as well, and I have stickers. So more about this later. Terraform AWS modules is the project which is a collection of reusable components for traditional things like VPC, security groups, RDS, and many more. It started more than a year ago, but a year ago, as well as release of Terraform registry, this became verified, and now they are used by lots of different people. So why Terraform? Right? This talk is about Terraform and something about it. So Terraform was created in about 2014, right? And the only purpose of it was to be able to write, plan, and manage infrastructure as code. This talk is maybe a little bit more advanced, and I assume that you know a lot of these things already, so I will not go in details, and I expect you to actually read documentation in addition to this talk. Documentation is excellent. So, nevertheless, right, so it works almost. So this is how a main TF file looks in Terraform. You describe some variables, you describe some resources, you have some dependencies between different resources, and as you, it's bad as you can guess. So you define some information about AWS region where infrastructure is going to be created. You define what kind of resources like S3 buckets or which will be created. You run some commands. Yeah, that's life. You know. Yeah. No, but that's how it is. Unfortunately, the projector is not so great, but yeah, I can read what is on the slide. So you run command Terraform init to download dependencies, and after that you run command to create these resources like Terraform apply, and it will show you what exactly is going to be created, and you confirm it, and then you have these resources created. right? So now slide on white background illustrates that different cloud providers over time come up with different solutions to Terraform, like before Terraform. For example, AWS CloudFormation was created by AWS with similar purpose. Google Cloud has come up with its own solution to deploy resources, and Azure eventually came up with something similar. But you may think why Terraform existed in the first place, right? The main reason why Terraform exists is that there are much more than this. There are more than 100 different providers which allows to configure different resources on different systems. And this is one of the biggest sales points of why people should use Terraform versus whether I have to stick with CloudFormation if I'm not going to leave AWS. No, you should not use CloudFormation. So Terraform is a universal tool for everything where we have an API. An API, believe it or not, exists even for Dropbox files. Even Jira issue can be created with Terraform. There are many different use cases when you want to be able to configure your resources like Datadog metrics or control permissions to different objects. So everything what is available through API can be controlled using Terraform. So now let's begin with more or less real projects, where at the beginning everything was fine, everything fit into single main TF file, and it was just fine, right? So we have, oh my God. Well, I cannot rely on this, sorry, but it's... That's a good idea. So many geeks in the room, we fixed. Excellent. But we have not fixed the clicker yet. So I will stay here, no problem. So on this slide we see how Terraform configuration looks when we just need to create a basic virtual private cloud within AWS. So it's simple, nothing special. But eventually your project will grow and you add different things into it. Right? You may think what exactly you're going to add, and you are going to add resources, regions, providers, whatever else you can figure out. You will integrate everything with everything. So it should remind you that you will continue editing main TF file, and now you just add internet gateway, right? Because you want to access internet. Good idea. Then a little bit later, you figure out that you need some subnets, and then you probably need something else. So you will add a lot of different things. And by the time when you figure out that you actually need to access internet from private subnets, you need to configure routes and routing table and all of this together, your network configuration in Terraform will end up in about 300 lines at least. It can be much more. So you may think, what exactly is going on with main TF? Of course it's growing. And it's growing approximately 10, 20 kilobytes for just networking stack with more than 300 lines of code. Dependencies eventually will get worse and worse. That's natural solution why we're here, is that Terraform come up with Terraform module. So Terraform modules is just a... Yeah, excellent. I don't know why it's... Oh yeah, now you can see it. Magic. So, yeah, actually speaking about modules, Magic Modules is a reserved name by Google. You can Google it. So, okay, yeah, I think so. So messed up. Right. So modules, it's really important to understand from Terraform documentation are just self-contained packages of Terraform configurations that are managed as a group. That's the only thing which you have to understand about modules from Terraform documentation. There are several types of modules. Like the first one, which is the easiest one and more very reusable one, because it's possible to open source and it's hard to invent something there. It is a resource module where just the resources can be created in different configurations. Nothing else there. As in this example, there is a way of using security group module of which is hosted on Terraform registry, and we specify that we need to use version 2.0.0, and we provide a bunch of arguments to this module. So that's all what we have. We have information, you may think what exactly the purpose of resource module, and the main answer is that such resource modules can be versioned, while individual resource block cannot be versioned. But if this is not convincing, then think about security group module, and this is real code within this security group module. It is creation of EC2 security group module in different configuration. Believe me, you don't want to write this code for your project, because I hope this is not your business, right? I mean, you probably don't earn on creation code in Terraform and selling it for security group at least. So the code itself is about 600 lines, and it can be very powerful way of abstraction. Next slide. Second type of module is infrastructure module, which is just a high level, because it consists of resource modules, and it often enforces something what is related for the company, like tagging, naming, and so on. And that's exactly where it makes sense to reuse existing tools like JSONnet or cookie cutter or different preprocessor, makefile, whatever else, to fulfill missing bits of Terraform 0.11. And infrastructure module invocation looks pretty similar. So we have module hosted on the registry, and we specify a bunch of different values which we pass as arguments to the module. Inside of this module, we are just invoking resource module for VPC, application load balancer, and many other things. So just to summarize, there are two types of module, resource and infrastructure, and resource is very reusable one. So let's look into how to write modules. So the first tip which I'd like to give is to not write resource module, but just check what is existing there. There are more than 600 modules published in the registry. Many of them are very good quality, so don't be creative unless you really need. Sorry, people. So if you actually decide to write some modules, then try to hide all this complexity, as I showed for security group, somewhere inside of this module. As in this example, people who are using the module, they don't really know difference between implementation of time zone in MS SQL versus MySQL. So they're just calling this module. And then inside of the module, we're creating resource based on certain criteria. Like in this case, if name was SQL Server, then create MS SQL. Otherwise, create MySQL and use time zone only for MS SQL. As an output of the module, we are outputting the only result which is available there. So user doesn't have to know that we are actually creating one type of database or another. Different implementation details are totally hidden. Second thing is size of the infrastructure modules. If you think that it's okay to just host all of your infrastructure modules in repository and just use part of it, it's often going to be cloned every time when you are invoking all of this. So your module will be just several kilobytes of code, while the whole repository is several megabytes. Then you will have to clone every time the whole repository, which is just inefficient, especially if you're making lots of small resources like IAM users. MBT is a good solution to split one big Git repository into several, and you can do this on build process. Few things which I'd like to point, which you have to avoid. So first of all, is never use providers in modules. And the only exception is that you may use logical providers like template, random, local, HTTP, external, but not in cloud providers or any other state providers. You may think why it's actually bad, because I did this and it works. Yes, exactly, it works for you, but it will not work for Petya or Vasa. Because the way how Terraform is invoking providers configuration is not possible to override. So if you put this code inside your module and you ask why people are not using my module, that's because of this, partially. Another thing is that provisioners itself are a pretty bad idea to use in all resources. I know that a lot of people are using them, but I just try to show why this is bad. Okay? Even if you are thinking that what can go wrong here, or I'm just going to use it in EC2 resources because it makes sense. Like my instance is created, then I'm calling Ansible playbook, which will just connect to this IP address. Yes, it's probably fine for some time. And what can possibly go wrong? So the good solution here is that if you can use things like user data on AWS instances, then use that one. If you can use auto-scaling group, then use that one as well. The benefit here is that if you start using provisioners, you will have very hard time migrate it into other project or into other, into just other project if you want to distribute it somehow. So the way when you actually you say that no, I absolutely must use my local dependencies and I want to use it to use my local machine when something is created. Then use null resource for that. Null resource doesn't create any physical resources, so that's exactly the place where such things can be implemented. And a few traits about good Terraform modules. I was working with Terraform modules for a pretty long time, and then I discovered that it actually makes sense to look around and think what are common mistakes which people are making and why they're actually mistakes. And I ordered this in the order of importance. The most important thing in Terraform module is documentation and example. And the least important thing is actually test. If you disagree with me, you're welcome to B or F, which will be tomorrow. Slide later. Feature reach is important feature of good Terraform module because it means that I can use your module and use it for my subset of things, and someone else can use, and everything should be fine. So that's really one of the core feature, because some people think that it works for me, I don't care, I will not improve it, that's fine. But if you want it to be actually good and reusable, then it has to cover as much as possible different situations. And never hard-code values like some things which are related to just your company or your project, things like environment name or company name or even tags. Everything should be customized or at least overridden. And make sure that your code is actually readable even by you after a couple months. It's a good suggestion because, believe me, you will be using GitLab to figure out that you wrote this code. Okay, so let's, I don't know, someone says that I have very few minutes left, but I think I have plenty of time. Just to summarize, we looked into how to write modules. So first of all, check out registry.terraform.io and find something there. It's likely to be excellent starting point, at least if you're not going to use it entirely. And avoid things like providers and provisioners at all in modules. Use it somewhere else outside. And let's look how to call modules. Okay, as we understand, the amount of resources still keeps growing. We figure out that we just made our module, we put something there, we somehow have to orchestrate this invocation, we somehow have to call one module and pass dependencies to another one, and so on. So let's look into different patterns here. So the first pattern is all-in-ones, where you have to declare variables and outputs in fewer places, but the blast radius is pretty big. You may use some things like -target as an argument and specify that you just want to take care of this specific subset of resources. It will work for some time, but it's not the ideal. And everything is blocked at once means that if I'd like to cooperate with some of my colleagues on this project, when they run it, I cannot run it. I cannot run plan or cannot apply it. I will have to wait. And if we are talking about resources like CloudFront, or if we're talking about Azure provider, things can take minutes, sometimes hours. So this can be very strange that you have to wait in 2019. So another pattern is one-in-one, where things are getting much more isolated, and it is possible to work in an isolated set where we have different responsibilities. For example, if we're working with VPC, it's unlikely that we're going to have to change VPC every day. But it's probably a good idea that it's going to be quite possible that we're going to work with application configuration code quite often, because we'll use GitOps and we'll change all of our TFRs file from CI server. So then it's a good idea to separate and make much smaller blast radius. But the only downside here, as I understand, is that we have to copy-paste a lot of variables and outputs if we want to use this pattern. So now let's, I don't see so many hands obviously, but the question is, what kind of ways do you prefer? Where things are organized like this? Can you raise your hands? Okay, at least one I see. No, two, okay. Yeah, but not so many. Okay, let's, who's using this pattern? One-in-one. Right, so much, much more. I can see this even now. That's really good. So, very few people raised hands all in one, but a significant amount of people raised one-in-one. Okay. So, and MFA is most frequent answer, actually is somewhere in between. Because it's very often when you start using something, you're not thinking like, oh my God, this is going to be my ideal project, I will make everything correct from first day, right? It's just not going to happen. So it makes perfect sense to start with something small and then iterate there, and then when you figure out that now I start to have some mass, then it's time to on top of it, right? So how I can actually invoke different modules, what can I do from there? And the question is, what kind of orchestration tools do you use? I can give you a hint that you can use -target, Terraform apply -target, and then specify some module, or you can use makefile to chain different invocation of Terraform init, apply, outputs, and many different crazy things. What exactly are you using? Like just randomly, who's using things like target or makefile and happy with it? Right, so it's pretty funny that I have so many questions and I don't see answers. But I guess it's 5, 10 people. Okay, so I have some good news for you. You can use Terraform for that as well, right? You can use null resource to invoke Terraform from Terraform. Isn't it cool? No? Just don't do this, okay? There are better solutions for versioning. But calling Terraform from Terraform is doable. I did it. But I did it just for fun to figure out that you had to treat Terraform a little bit differently. It's not made for that. Okay, Terraform was designed to run just things linearly, where you change file, you run plan, you run apply, you see output, and you can continue running the same things to verify that the infrastructure has not changed. But if you're actually thinking about orchestration in Terraform, the best tool out there right now is TerraGrant. TerraGrant is open source. It's written by Grantwork people, and lots of users worldwide are using it to exactly invoke and chain different invocation of infrastructure modules. So how it looks. The Terraform TF vars file has configuration block where it's specifying where and also what kind of dependencies this module has. In this example, we are calling EC2 instance module, which means that network stack has to be dependencies. And also we just specify what basically pass into this model, and that's it. So the whole configuration of Terraform is abstracted because it's hidden within this Terraform model which we just invoked. It's pretty good. You will think like, yeah, but TFRs cannot contain dynamic values, and who should have this need? Who doesn't like to hardcode values of subnet in one place and then remember to update it in another place? Some of you may have this need, yes, sometimes. So Terraform cannot contain dynamic values, so I fixed it. The way how I fixed it is I wrote shell script for that. Really. So that's the only thing which it was very easy to make it, and it works quite nicely. Because everyone has configuration log like hooks before, hook, and after hook. So before running plan or apply, I just run the script to make sure that I actually fetch information about subnet, BCAD, or a bunch of other things which were previously combined, and put it into TFR's file. If you want, you can use modules TF for that. Right, so we just looked into how to call modules, and now let's look into how to actually write or how to work with code. If we have new features into our Terraform configuration, usually it's easy. It's really nothing to out here. But what if we want to use existing infrastructure resources like VPC? Because we started with one big main TF file, we added a bunch of things there, we created VPC there, and then we discovered that, oh no, now I have to use this VPC as an argument to another module, or somehow connect this, or somehow separate the whole thing. The pattern here is that we use data source and we use resource together. Data source will pick up if ID was present, and resource will be created if it is not present. And again, the output of this value will be the first not empty value, which is there. So, if we're working with a list, the problem with Terraform 0.11 is that lists in Terraform have order, which means that if we are having a list of IAM users, user 1, 2, 3, 4, and then we want to remove user 2, then it means that user 3 and 4 will have to be recreated because their IDs or their placement has changed. For some resources, it's totally fine. But what if we actually create IAM users which are, and IAM access keys which are stateful? I mean, when someone whose name is after my name leaving the company, or before my leaving the company, I don't want to have new IAM access secret key generated for me. Right? It will be very strange. Then person with last name starting with Z will have new IAM key every day. That's not going to help you. So the solution here is that if you need to work with stateful list, you may use tools like JSONNet. JSONNet is open source and it's available as CLI, where template for it looks like this, where you configure, no, this is actually not template, this is an output. This is template. Oh my God. So the template here is written in JSONNet format. And as we probably know, JSON and HCL are compatible. We can use JSON file as well as HCL, and Terraform will recognize them. That's why generating of JSON is usually easier than generating of HCL. So if we run command like this, then the output will be a collection of modules for each individual user. And if we run Terraform init and reply, it will just take care of these users. It will not remove anyone from anyone in the list who's after. Another thing is related to integration. It may think that Terraform has everything what I need, but there is no way to do, let's say, specific feature, because Terraform is not always up to date with recent announcement by AWS. And if AWS announces something, it's likely that it will be supported in near future, but probably not right now. So there is still need to use some things like AWS CLI, where we can just use output from one command, from one resource, and execute it in shell. If we need to use auto integration, then we again may use null resource for that. There are a bunch of edge cases, which I'd like to talk tomorrow during BOF about infrastructure testing. But just a small subset of these problems and edge cases is that different AWS regions as well as different AWS accounts have different things, like version of S3 signature, whether EC2 classic link was enabled in this account before or in this region before, whether IPv6 is available here, or maybe it's not going to be available, or maybe IPv6 was there all the time. All of this will have different effects in how you write Terraform. So be very careful and think carefully where this specific code will be executed. And also, what is the soft limit of resources in AWS? Like, you may think that it works in dev environment because I'm using something very small, but it will break in production because you have limited amount of IP addresses, for example. So just be careful about that. And there are a bunch of things which I'd like to mention related to if you are willing to use Terraform in a way that you remember the command which you wrote last time when you work on this project, then the best command is actually no arguments at all. So that you run just Terraform apply or just Terraform init and don't specify any arguments, especially if it is not secret. I mean, if it is not secret, then you put it into TFR's file. If it is secret, then you use it as an environment variable, and it will be loaded or picked up by Terraform. But it's a pretty bad idea to remember that you have to run Terraform apply and then specify two variables and remember order of var files which you have to write. It is very easy to break, and you will just make problems for yourself pretty soon. And also, you think that using target and parallelism is a good idea because I have big infrastructure and I just want to work on this specific area, and it works very fast, so I will just keep running with minus target and don't care about the rest. It will be probably fine for some time or for really small edge cases. But if you keep doing the same things over and over, you will simply not be able to answer question what kind of configurations I have on this environment or in production or in dev. Because you always use targets, so you didn't run it for everything. And Terraform Workspace is evil for majority of cases. I've been in this discussion many times, and I'm glad that Terraform documentation was updated not very long time ago, where they actually explained quite nicely why and what exactly workspaces were designed for. Because there was huge amount of confusion where people thought that I can just use workspaces for dev, stage, and prod, and everything will be fine. No, it's not going to be fine. And the reason why it's not going to be fine is that very soon you will have differences between your environments, and something will not be as equal in dev, while it should be equal, and huge amount of complications you're just bringing to yourself, as well as dependency hell in module. Terraform does not have a good pattern of using or specifying dependencies between modules, so there is no magical requirements txt or package JSON or whatever else we get used to in other languages. There are some attempts by community to write Terrafile where modules will be configured in one place and we can sync them together, but it's good just for the highest level. Don't try to use module in module in module in module simply because your file system supports symlinks. It's not a good idea. Just one or two levels maximum is enough. So for the time, as another type of summary, I'd like to highlight that I think the best thing or the best advice which I can give is to perceive Terraform easy. Even if it has CLI full of 20 or 30 different arguments and you think that you will need all of them at once, try to not use all of them. And you may think why it is so, because somebody wrote them, so I have to use it. And if you're even curious why it says for the future in the title, right? Because there will be 0.12 eventually. There are some core contributors to Terraform in this room, somewhere there. So you may ask questions later and they will be able to answer, I hope. But the point of 0.12 is that you may think, you may be very excited that HCL2, wow, simplified syntax. Cool, so I have to start using 0.12. Loops are going to be there, so I can use all countless for loops for each for dynamic blocks. And finally, left and right part will not be executed simultaneously in conditionals, and I can use conditional operation properly, and many, many other things which you think you need. But this was a pretty good blog post written a long time ago. But what I just tried to figure out from the community is that a lot of people think that 0.12 is what they need. Just because I have these problems with my code for some time, and 0.12 has all of these features, so I will just start using it, and it will somehow make my code easy. I personally don't think that it matters so much. 0.11 had lots of things which people were happy with. We created lots of things using it. It was fine. But with the amount of features which 0.12 is bringing to developers, I'm afraid that a lot of developers will try to use much more of these features in Terraform code, and it will be just very easy for them to make another sort of spaghetti code. The way how Terraform 0.12 has to be used and where it's particularly beneficial is just for writing Terraform modules itself. So that when you're thinking about, I need to make a module for S3 buckets. By the way, this is one of the modules which I couldn't write for the last 2 years because there are 225 permutations, and I don't want to make 225 modules. So if I'm using 0.12 in order to use dynamic blocks and for loops and so on inside of module, then it's great. But I don't want developers who fall in love with HCL, with easy syntaxes, and they say that, oh my God, JSON is bad, but HCL is excellent. And now I have to tell them that, oh, by the way, you can use loops, and don't forget that you can use this and this and this. It will be just another level of complexity for them. If you really like 0.12, then put all of your knowledge into writing modules and not let your developers who are just starting, especially Terraform learning, be overwhelmed with the amount of features. And I really encourage to use existing modules and utilities provided by the community. I'm sure there are some people in this room who wrote some utilities, so thanks personally for all of you because I use a lot of those tools. I have some bonus. This one. Now I can see who was sleeping. Right. So not many were sleeping, so that's good. So some of you may saw this before. So this is a tool called CloudCraft, where you can visualize your diagrams of your AWS infrastructure, and you connect different boxes together. You can think about what kind of properties or attributes all of this has to have. And about a year ago, I was thinking like, yeah, but we have Terraform, right? We have infrastructure as code. We have AWS console, which people should never have access to because there is code already, so why you should be able to even manage something there. So it's kind of not exactly the point. And a year ago, I was thinking like, it would be probably a good idea to make generation from this visual diagram from Cloudcraft into Terraform AWS modules. So using Terraform AWS modules as building blocks for AWS infrastructure, and use Terraform as a tool to actually call all of this. So that's why approximately 2 months ago or so, I open sourced this, and it is infrastructure as code generator, which gets your visual diagrams, which your cloud architect love and draw, and give you some information as Terraform code. And you can try it like this, but some of you may think like, yeah, but we've already saw different bootstrappers, which we just, not bootstrap, but boilerplate code, which we just create hello world, but it's not actually practical, and we just delete it immediately. That's why I paid lots of attention to how to write it, like to be as close to ready to use as possible. Take a lot of amount of attention to all details, connections, and actually enforce Terraform best practices by installing and configuring different tools like pre-commit hooks, Terragrant, and so on. It is open source, and if you like AWS Lambda and Python, you may try to look and open issue there. And yeah, that's it. So there will be some we still have some time. So yeah.
Speak loudly. Please don't get up and start moving, because that will disturb the question round, and we have a little bit of time.
So thank you very much for the talk. In all of the time that you spent with Terraform, what is your preferred state management and state locking system? I know it's kind of off topic, but...
State management, you mean S3?
Yeah, and locking. How do you make sure that it's locked?
Yeah, so the question is about state management. I hear this question pretty often from not AWS users, because Azure doesn't have any blob storage which is usable. Right? No, I mean blob storage. I mean if you say that you don't want to lose this file and then you delete this file, you actually lose it. That's not state management in Azure. So a lot of people are happy with whatever they have easily available. If they already have console installed in the network, in the infrastructure, then they keep using console for the rest of their life. But if it's just a new project which started from zero, then S3 will satisfy your needs for a very long time. And I personally have not heard almost anyone who's using something else. I mean, of course, on Google you can use whatever Google provides, but I have not met anyone who's saying that, oh, we are using just solution X. So console, S3, and that's it. And for lock-in, answering question about lock-in, it's also whatever you have in place. Most of people will never meet any challenges with DynamoDB, and it works just fine.
All right. Any more questions? One more time, I asked if you could please not start moving, because it's really disturbing for everyone who is interested in the question.
Well, thanks for the speech. I would like to ask, I don't know if in your experience have seen something like that, but sorry. I don't know if you have seen in your Terraform live something about like changing from current modules that you are using to CloudFormation stacks. As far as I know, there's no tool for that right now. I don't know if you have any.
Yeah, so it's really an interesting question because once people start using Terraform, they are almost never looking into anything else. Right, I mean, there are some competitors, but it's not CloudFormation. So even if people are with AWS and they say that we are not going to leave AWS, we are quite happy with CloudFormation, it's unlikely that they will suddenly stop using Terraform and continue using CloudFormation. There are no tools as far as I know, but there are some quite easy ways how you can do this. Since most are pretty well documented, you may have some guess. There are tools like Terraforming to generate Terraform configuration code based on your existing infrastructure, so that you run Terraforming and it will give you HCL snippet for this specific resource, which you just copy-paste, and it will be able to adopt existing resources into Terraform state as well. But there is no need for this. I have not heard, as you mentioned, my Terraform live about upgrade.
I think that on this topic, where we've seen it is that every once in a while you see these CloudFormation stacks that are like fully developed, and to convert something like that to Terraform is not always easy. For instance, the AWS landing zone stuff is like a huge CloudFormation stack. Yeah, and so I haven't seen a proper Terraform landing zone.
Answering or adding information about migration from existing resources is not an interest of AWS to let you go, right? So they clearly have something internally. They pay attention quite clearly what's going on in the market, but it's not something what they're interested in doing. That's why you don't have even access to state, right? You cannot do anything with state, so you have to literally kill this resource and start it in another place. In many situations, it's not acceptable.
All right, thank you very much. Now we can move.